Hey YouTube, Tire Metalhead Weatherman here. Hopefully you guys are doing well. In this one, we are going to actually be going back to the Weather Nerd 101 playlist, and we will be talking about a very big topic, especially as of late, and that is the polar vortex, and we're also going to talk about a couple of oscillations and weather patterns that are very prevalent to said vortex. So, before I get into it, hope you guys, of course, have been doing well, and you know what to really do here. Hit that like button, subscribe if you haven't already, and of course, share this video to anyone that would like to learn about why sometimes our cold weather just goes to absolute. Never mind. Anyway, what is the polar vortex exactly? That's probably what I'm thinking a few of you might be asking. So the polar vortex is pretty self-explanatory. Right around the North Pole, there is a large pocket of cold air that exists, and it is surrounded by what's called the polar jet stream. We have two jet streams over this hemisphere, the polar jet stream and the subtropical jet stream. Subtropical jet brings in warm air, polar jet stream brings in cold air. I have a whole video that discusses those two jet streams in further detail towards the beginning of this playlist. That being said, let's go ahead and talk about what a stable polar vortex looks like, as indicated right here in this diagram. When the polar jet stream is stable, moves in a circular counterclockwise motion in a vortex-like pattern, and that cold air ends up staying contained. But what happens, this Arctic polar vortex will sometimes end up having a situation where we end up seeing massive surface or stratospheric heating occurring, and what will end up happening with that is, as a result, we'll start to get some amplitude going in that polar jet stream, as we see here. And in those troughs, just like I've mentioned in many other videos in the past, when I look for severe weather and other sorts of extreme weather events, that cold air will often move within those troughs and sink to the south. Basic science right here is simple as this: cold air sinks, warm air rises. Hence why we see the ridges and the troughs. So, in other words, basically, whenever we hear about a disrupted polar vortex, this is what it looks like. So, one thing I want to note as well is the fact that not every cold event is linked to the polar vortex. There are other events that can cause this, but this is probably one of the more extreme forms, not to mention that the polar vortex doesn't really sink that far south that often, or at least not until recent years. Global warming may play a part in that. That being said, let's go ahead and take a look at what an active polar vortex looks like. This is a diagram that dates all the way back towards January 2019. We can see a couple of pockets right here where we're getting into, where we have some heating going on towards the surface, all the way out towards the Pacific. And as a result, the heating was sufficient enough to influence the polar vortex to start moving in a more disruptive pattern. And as a result, a piece of it broke off, sunk down towards the Midwestern U.S., and a large part of the Southeast even. So we were seeing below average temperatures, and some of that coldest air was starting to make its way towards the northern plains and even parts of the Great Lakes. So basically that's what a polar vortex can look like. Again, as we can even see here, not all cold events are caused by the polar vortex, and really it's not that rare to have these events occur. They're very common, especially towards the northern plains. But when we see an event like, say, what we saw around Christmas of 2022, that's when we have to kind of analyze things a little bit more. And like I said, it's a pretty simple situation here. We were seeing extreme heating going on around, usually this will end up being off like the coast of Africa or around the Aleutians. And what will end up happening is that cold air will get funneled in from a blocking high in towards the northwestern U.S., and then eventually it'll linger across this region something something will influence it to move otherwise. There's also a blocking high that'll sometimes set up, usually around the Azores, which is right around this region here. And this is an oscillation, which we're going to get into later. But what that oscillation will end up doing is forcing that cold air off towards parts of Europe too. So this polar vortex isn't just a big deal for the US, it's a big deal for the entire planet. So you can even see it indicated here, where we can see that cold air starting to funnel this way, coming over the US, and then heading back more so towards the northern parts of Europe, and even heading towards some parts of far northern Asia, even potentially. So that being said, is every polar vortex event equal? Not even close. Like I said, a lot of this depends heavily on the surface or stratospheric heating even. And there's other little variables that I'm not really able to get into unless you want a 2-hour-long video. But that being said, let's go ahead and take a look at what our current situation is as we start to look towards March of 2023, which is around the time I'm making this video. So we'll start out by moving this out to about 6 hours ahead of schedule here. It's the latest model run that I have from the GEFS ensemble. So we'll run this forward here. And this is what we have going on around the North Pole, and this is the North American continent here. So as we drive this forward, you can see just looking at this right here that there's already been a disruption in the polar vortex. We have a little bit of warm air that snuck in across this region here, and this is more so over towards Asia, like I've said. And here is that blocking high that's developed around the Gulf of Alaska and towards the Aleutians, or actually I think the Gulf of Alaska is here. Correct me if I'm wrong in the comments, feel free. Let me have it. Anyway, that being said, we can see this blocking high taking shape here, and watch what happens as a result as I move this forward. About 100 hours out or so, we can start to see this blue bowling ball here, and this is indicative of very cold air coming into the northwest region of the US. And as time goes on, this piece of polar vortex extends outward and eventually gets caught in the subtropical jet, and eventually will start to move off to the east. This is often why we end up saying, whenever we watch for these patterns over here towards the west, we often will watch them doing, watch what they're doing, because whatever happens out west, eventually at some point it will move to the east. And this is exactly what we start to see here. And whenever we have this warm air set up like this can also lead to severe weather events. We can also look at ice storms. Other various events can be caused by this. It doesn't necessarily have to be frigid to kingdom come in order to have a significant weather event of some kind. But just know, whenever there's a polar vortex event going on, pay attention to the weather, because there is some chance that you will be affected by it in some way, shape, or form. So here is another piece of that air from the polar vortex coming in, and this will start to affect the eastern half of the country towards the end of this model run, and this is heading into the first week of March. We can start to see eventually a chance for some stability developing towards maybe the middle of March, but considering how far out we are in this model run, it's more or less hearsay at this point. The ensembles, I feel like they do a better job than the operationals, but you can't take this kind of stuff for granted, and you can't just try to jump on making these kinds of forecasts off of just hearsay. It's foolhardy. But anyway, that's what we're potentially dealing with right now. Now, there's a couple of oscillations here that influence that. And you're probably wondering, okay, what is an oscillation? So an oscillation is a shift of position of various high and low pressure systems, which can help influence cold and warm weather events So if we go back to that model display here, low pressure is usually an area that's going to have cold air associated with it, and it's indicated in the blue. And the warm air is going to be indicated in the red. That's usually going to be a high pressure event when you have warm air associated with it. Where these two end up clashing, there can be fireworks. But as we saw earlier, notice how whenever we watch these systems roll around, look at how where that warm air is, that cold air ends up moving around it. Here's a ridge right here, that trough develops right here. These all influence the jet streams, be it polar or subtropical. So we end up seeing this storm system move off here, and then we end up seeing the potential for a severe weather event as a result of this ridge that develops here. So we'll see this move around, and we'll watch that cold air go along this track here as it gets caught up by this part of the jet stream that's broken off here. So then this warm air moves here, and watch what happens over time as that starts to weaken. This cold air will kick out that warm air. These two will never be rarely do these two ever end up being in the same place. But that basically is a general idea of what an oscillation is. Now, the oscillations that we look at in particular are usually areas like this right here and this right here. This would normally be this one right here is called the Arctic oscillation. I think this one is the PDO, or Pacific Decadal Oscillation. And then there's the NAO, which is usually around the Azores, which is right about here. It's usually associated with a blocking high, especially towards the summer. I'm mainly going to be talking more so about the Arctic oscillation in this one. All three of these can be relevant to winter weather, but we're mainly going to be talking about the Arctic one. We're going to talk about the NAO and PDO in regards to hurricane season, which will be down the line. That being said, let's go ahead and talk about some of the definitions here behind these. So the Arctic oscillation is the one that's closest to the polar vortex, and there's a negative and positive phase with this. The negative effect basically brings higher than normal pressure over the polar region, and the lower than normal pressure at about maybe 4 to 5 degrees northern latitude. This negative phase will allow much more cold air to plunge further southward. So whenever you see a negative AO, even if it's for a temporary period, it's something to keep a close eye on. You will not hear most of your local meteorologists talk about this, obviously, because it's not necessarily prominent to their area, but this is a huge part of the weather patterns that we will end up seeing, especially during particular times of year. So that's one. And then we can also take a look at the North Atlantic oscillation, or NAO. I may have touched on this maybe once or twice on this channel. I haven't talked about it much, but I do intend to talk about it more over time, especially as we get into hurricane season. This is very prevalent as to our tropical system storm tracks, and also our winter weather storm tracks as well. A positive or negative phase will determine a lot with this one as well, and we'll briefly touch on that in another video. And then, of course, there's the PDO. PDO is also heavily linked with ENSO, which is the ENSO or El Nino or Nino Southern Oscillation. So we'll have to watch that. So we always watch these very closely in regards to hurricane season. Although this is more so based off a time scale of decades, more so than season. But it is characterized by strong stratospheric anomalies. So we'll have to keep an eye on that, especially during the wintertime, because this can often cause snowstorms around the Northwest, and then maybe even influence the jet stream to the point where we could even get snowstorms that are a little further to the south than what we are used to. That being said, those are the main three that we look at over the U.S. Like I said, today we're mainly going to be going over the Arctic oscillation, and these other two will be coming up in a later video along with ENSO. So to put it simply, here's a look at a negative phase oscillation right here. We can see the low pressure areas indicated in areas in the gray. We can see the high pressure develop here. So basically, this is almost identical in nature to a disrupted polar vortex. In a positive phase, we can see that jet stream is a little bit more zonal versus amped up, or you see the increase in amplitude here. You see much smaller waves, much more stable look to it. The high pressure is developed here. Low pressure will be contained more so up to the northern poles. So with that, whenever we see the positive phase, cold air is a lot less likely, and you can have an average or maybe even an above average winter. A lot of that's going to depend on the other oscillations around the U.S. Now, one other thing to note here is a pattern that I talk about a lot more, though, and that's called the PNA, the Pacific North American pattern. So the Pacific North American teleconnection pattern, or PNA, as I say, is probably the most prominent mode of low frequency variability within really this entire hemisphere, not just the U.S. So basically, I'm going to show you a diagram, because I've mentioned it probably 1,000 times, of what a positive PNA pattern and a negative PNA pattern looks like. And this is kind of looking more so towards our current situation here. This is a negative PNA pattern. It's pretty simple, really. It's cold out towards the west, warm out towards the east. And basically, if you're looking to try to understand, okay, well, that's a negative PNA, and you've talked about that forever, what is a positive PNA? I will show you. So if we look at this setup right here, a correlation right here, we see a positive PNA pop up here over towards this October time frame. October, we see this warm air sneaking into the western half of the country, and that cold air will be stationed across the eastern half. This is what you call a positive PNA. PDO heavily influences this, as that blocking high around the Aleutians, depending on its position, can often allow a strait for this cold air to move, or it can basically keep that cold air funneled out from parts of the U.S. Or it'll have that cold air sneak into a pocket where it just basically dissolves. Like I said, these two air masses cannot exist in the same place for too long. One of them is eventually going to win out. That's just how it works. But simply put, the main things to be concerned with when it comes to winter weather, the basics of it are the polar vortex, Arctic oscillation, and the NAO. PDO is a little bit more relevant than what some may realize, but it's not quite as big of a player. It's definitely a bigger player when it comes to hurricane season, especially out west. But all of these are still important at the end of the day to keep track of, so that way we're up to date when it comes to the weather, especially when it comes to making forecasts. But that's the end of this video here. I hope you guys enjoyed. If you did, you know what to do. Of course, drop me a like. Always appreciate that, as these videos are a little tougher to make, because I always try to make sure I'm updated on my info here, even though I still make mistakes sometimes. That being said, hope you guys enjoyed again. It's been Metalhead Weatherman. I'll see you guys in the next video. You guys take care till then. See you soon.